today's session. Now see, in our day-to-day life, so many questions arise in our mind. Now see, if we are seeing at the top of the tree, what do you feel, how to find the height of the tree? Or by seeing the church, we feel like how tall it will be. Or we are at the seashore and observing the ship in the sea, then what we feel, how far we are from the ship, how we will find out this distance? By actual measuring? Is it possible to measure actual distance of all these things? No, it is not possible. Now this is possible due to applications of trigonometry. Now we will see how to find the height of the tree, height of the tower, or how far is the ship from the seashore, or a person is observing the ship from the tower, then that also we can find out. Okay, this is everything is possible due to the applications of trigonometry. For the three basic things we must know. Now if we know to use this basic concept while solving the example, this type of examples will be very easy. And see, definitely one question is going to be from the trigonometry, that will be the word problem. See, because they have said now one question will be out of the textbook. So this type of question can from trigonometry, out of the question they can ask out of the textbook. Okay, so what the basic things are necessary, that we will see now. And see, while solving the example, rough figure is must. What you understand from the question, that you have to represent in terms of the figure. Okay. Now see, first thing is what? The line of vision. Now line of vision means what? Now see, I am standing here and I am observing towards you. And this is my line of vision. Now if I represent it on the blackboard, then how it will be seen? Now see, here this A we will consider as the observer. Now he is observing, this A is the observer, he is observing at the B. Okay, so this will be, AB will be the line of vision. Okay, line of vision. AB is a line of vision. Now next we have to find, the next thing is what? Angle of elevation. Angle of elevation. Now angle of elevation means what? Now see, A is the observer and he is observing at the B, and it makes a horizontal line to the with the ground. Okay, so the angle formed here between the observer and the vision, that is called the angle of vision. Means he is observing at the B and it makes a angle with the ground. This line is called as the horizontal line. What? Horizontal line. And this is line of vision, means where we see that. Now it makes an angle while seeing from bottom to top, that is line of angle of elevation, means from the ground to up which we see, this is called the line of angle of elevation. Now see here, angle formed is what? Angle BAM is the angle of elevation. Okay. Now if somebody is observing from the top, like this we'll see at the bottom, means what? Now here, in this case, A is the observer here. He observes here, he observes at the B. This A, he observes at a B, means he will be observing like this. Okay, so this will be what? This will be the angle of depression. This is horizontal line and this is line of vision is seen here and seen at the downward direction. It makes a angle here with the ground. This line is parallel to the horizontal line. Okay. Now this is called the angle of depression. Okay, angle of, next is angle of depression. Angle of depression. Now see this, which type of angles they are? Alternate angles there. As this line is parallel to this horizontal line and this line of vision is the transversal. So these angles are the alternate angles. So alternate angles are congruent. Okay. So therefore now this angle of depression. Now this rough, in this all rough type of figures you have to draw. Now let's see the example how to solve it. Okay. Now see this all you have to write angle, line of vision, angle of elevation, angle of depression. You have to write it in the notebook. Now see the question. Now first I will explain you the solved example and afterwards we will move to the exercise. Now here see first question. An observer is at a distance of 10 meter from a tree. Looks at the top of the tree. The angle of elevation is 60 degree. What is the height of the tree? Now see here this is the observer. Suppose this C is the observer. Now C is the observer. He is seeing at the top of the tree. Means here A is the tree here, top of the tree. Now he observes here. He observes here and makes an angle of 60 degree. How much angle he is making? 60 degree he is making. And how far he is from the tree? That is 10 meter. Okay, means this figure we have got. Means what you want to find? You want to find the height of the tree. This height of the tree you have to find out. Now here see, he makes this distance is always perpendicular. Okay, so now which figure is formed here? The right angle triangle has formed. Now we know the trigonometric ratios. By using this we can find the distance. Now see here you have to write the statements. Now what statement you have to write here? Now let AB be the height of the tree, which is equal to A. Now BC is the distance between the observer and the tree. Okay. And angle is what? Angle ACB is equal to 60 degree. Angle of elevation. Okay. Now we know the relation between here see angle we have. Now is here which sides we know? This is adjacent side and this is opposite side. So 60 is opposite side and adjacent side. This relation is of what? Tan. So tan 60 is equal to what? Opposite upon adjacent. Okay, using this relation we can find out the opposite side. H we can find out. Now here tan 60 and adjacent side is 10, opposite side is H, that is you have to find out. Now what is the value of tan 60? Tan 60 is root 3. Okay, root 3 is equal to H upon 10. Therefore H is equal to what? 10 into root 3. Now here if the root 3's value is given in the question, you can substitute and you can multiply to it. And if it is not given, then you can write like this. Okay, like this you have to solve the example. See, everything this word statements you have to write. Now here as the place is not sufficient, I did not write. It is given in the textbook. These are the solved examples. Exercise examples I will tell you how to write. Now next question, see on page number 134 it is given. From the top of a building, an observer is looking at the scooter parked at some distance away. Makes an angle of depression of 30 degree. If the height of the building is 40 meter, find how far is the scooter is from the building. Okay, now what he is telling, from the top of the building, an observer is looking at the scooter parked at some distance away. An observer, he is standing at the top of the building. Okay, now see, here is the observer. Suppose he is the observer. He is standing at the top of the building. He is observing the scooter here, which is parked in the parking, or which is at the down of the building. He observes to it. Okay, and makes an angle of depression of how many degree? Makes an angle of depression of 30 degree. Okay, he observes down and makes an angle of 30 degree. Means this is will be what? 30 degree. Okay, now what happens? That he observes down. Now front of that, what if the height of the building is 40 meter? Now suppose this is what? The height of the building. This is, we will give as B. This height is 40 meter. Now as I told you, now this distance is always parallel to this. Okay, so this angle is 30 degrees. So this angle also will be 30 degree. Okay, now here see, this 30 degree. Now what we want to do it, this is 90 degree. Okay, now we have got the figure. Now we know the trigonometric ratios to find this. So for that, first what you should write the statements here. Let AB be the height of the building and BC is the distance where the scooter is parked. Now what we want to find out? Find how far is the scooter from the building. So this distance, BC is the distance, how far the scooter is parked from the building. This we have to find out. Now we have the relation of trigonometric ratios, that is of tan theta. Tan theta is what? Tan 30. Tan 30 is opposite upon adjacent. Okay. So opposite is 40, adjacent you have to find out, and tan 30 is what? 1 upon root 3. You can find out. You can represent this distance as BC, or you can write let the distance from the distance of the scooter from the building be x. Like this you can denote and you can find out. Okay. Now see the next example. Now solving it is given in the textbook. You can see. But to understand it is difficult. So I am showing you this all examples. Okay. How to represent in the form of figure. Now see next example. Now see next third example which is solved in the textbook. To find the width of the river, a man observes the top of a tower on the opposite bank, making an angle of elevation of 61 degree. When he moves 50 meter backward from the bank and observes the same top of the tower, his line of vision makes an angle of elevation of 35 degree. Find the height of the tower and what is the width of the river. Now see, a man, he is what? A man observes the top of the tower on the opposite bank, making an angle. Now suppose here is a man, he is standing here and he is seeing at the tower. Now suppose this is a tower, suppose this is thing A and B. This is the top portion of the tower. Now he observes to the top of the tower, making an angle of elevation of 61 degree. Means this is what? 61 degree. This is his line of vision and this is the horizontal line. Now this distance is x. Okay. Now and again what happens? From here he moves front. He moves front and what? From here how much distance he walks? 50 meter he walks. And again see at the back, at the top of the tower. At the top of the tower he see and makes an angle of 31 degree. 35 degree angle of elevation he makes. Means this is your line of vision. Now see, here we have got, now this is the what height of the distance, this width of the river. So what you have to do it, you have to write, let AB be the height of the tower and BC is the distance, or you can say the width of the river, and here this BD, you have to write BD is the total, that will be what, find the height of the tower and width of the river. Now this total, how much is the width, that we have to find out. Okay. Now see, here first we will consider this. Now this distance will be what? This is the right angle triangle. So you have this. Okay. So you will find this distance, in that we will get x value. You have to consider this angle, opposite angle upon adjacent side, opposite side upon adjacent side. So we will get the x value. Using x, considering this angle, we will get the h. Okay, in this way you have to solve. It is given in textbook how to solve it. Now see the next example, fourth example. That is, Roshni saw an eagle on the top of a tree at an angle of elevation of 61 degree. While she was standing at the door of her house, she went on the terrace of the house so that she could see it clearly. Now see, first she saw from her door that eagle was not visible to her properly. So what she does, she went on the terrace and from she tried to see the eagle. The terrace was as a height of 4 meter. While observing the eagle from there, the angle of elevation was 52 degree. At what height from the ground was the eagle? Okay, so see, first what, suppose here the Roshni, here this is the door and here the Roshni is standing. So she observed the eagle at the top of a tree. Suppose this is the tree and here she saw an eagle. Now making an angle of how many degree here? She made an angle here of elevation of 61 degree. Now from here it was not visible to her properly. So she went on terrace. So terrace height is how much it is given? 4 meter it is given. And from there she observed the eagle. Now she observed, making an angle of how much degree it is? 51 degree. She observed it is 52 degree. Okay, this is 52 degree. She observed an eagle. So we will give this name as A. Now from here, what? We have to find out what? Over. While observing the eagle from there, the angle of elevation was 52 degree. At what height from the ground was the eagle? So this will be what? This will be the height of the eagle from the ground, that we have to find out. You can give this name, any name you can give here. Okay, so now see here, this the figure formed is the rectangle. Okay, this now this is not given, so this is x. So this opposite side of a rectangle will be x. This is 90 degree. This is 4 meters, so this also will be 4 meter. Okay, so first using, and this we will consider it as y, this height. So first find out using right angle triangle, this C, ABR, find out the first this x. Okay, and then using this you find out this is x, this x. So this height you will get, this height if you will get, both add it so that you will get the complete height of the eagle from the ground. Okay, now next example, see, a tree was broken due to storm. and its broken upper part was inclined that its top touches the ground, making an angle of 30 degree. Okay, with the ground. So the distance from the foot of the tree and the point where the top touches the ground was 10 meter. What was the height of the tree? Now see, here this figure how we will draw it. Now what? A tree was broken due to the storm. Suppose this is the height of the tree. Okay, here A and here we will write B. This is the tree. Now the tree is broken. Okay, at this point, suppose this point the tree is broken. This part is broken, and what happened? The broken part is touching the ground. See, so a part was inclined that its top touches the ground, making an angle of 30 degree with the ground, and the distance from the foot of the tree and the point where the top touches the ground was 10 meter. Okay, means this distance was how much where it touches. Now this broken part it touches here. So this distance and this distance is same. This is the broken part. Okay, here AC is the broken part of the tree, and this distance and this distance is same. This make an angle of 30 degree. This is 10 meter away. Now you have to find out this distance. You have to find out x. X you have to find out. Okay, now so using trigonometric ratios you can find out this distance x, and after getting this using theorem of Pythagoras you can find this distance also. Okay, now see the next. Now exercise 6.2 we have to solve now. Exercise 6.2. Is 6.2. In that first example. Now first example is what? A person is standing at a distance of 80 meter from a church, looking at its top, and the angle of elevation is 45 degree. Find the height of the church. Okay, now see, suppose here is the person. You will see C is the person, he is standing and he is looking at the top of the tower, making an angle of elevation of 45 degree. So this is A and here it is B. Okay. So now this, how far he is standing from the church? So a person is standing at a distance of 80 meter from a church. 80 meter he is standing from the church. You have to find AB's distance. We will denote this as H. Okay, so for this what we will write? Let AB be the height of the tree. Height of the church. Then next is BC is the distance between the observer and church. Okay. Now making an angle of elevation, angle ACB is equal to 45 degree. Okay, angle of elevation is of 45 degree. Therefore, what we will write? In right angle triangle, in right angle triangle ABC, tan 45 is equal to opposite side, means AB upon BC, which is equal to H upon 80. Now we know tan 45 is what? here tan 45 degree, which is equal to 1. Tan 45 is 1. So 1 is equal to h upon 80. Therefore, h is equal to 80 meter, which is equal to 80 meter. So what is the height of the church? Therefore, the height of the church is 80 meter. Okay. Now this examples we have to write it in the notebook. Now next example which we have to see. Next example, see. From the top of the lighthouse. See next example. From the top of a lighthouse, an observer looking at a ship makes an angle of depression of 60 degree. If the height of the lighthouse is 90 meter, then find how far the ship is from the lighthouse. Now see what is said. From the top of a lighthouse, an observer looking at the ship. Now see. Second example. Suppose here this A is the observer. Now what he is doing? He is observing to the ship. So here you will write A and this as making an angle of how much? Making an angle of depression is 60 degree. Making an angle of depression of 60 degree. This is what horizontal line and this is line of vision. That is, he is observing to the ship. Now this see, this as it is parallel, these are parallel. So this is the transversal. So this will be the alternate angle. So this also will be 60 degree. Now what he said? Now he said that ship makes an observer looking at the ship makes angle of depression of 60 degree. If the height of the lighthouse is 90 meter. Now suppose this is the lighthouse. Okay. Now this is the lighthouse, means we will give it as B. So it is how much tall? It is 90 meter. 90 meter high is the height of the tower. Okay. Height of the lighthouse. Now next is what they have said. Then find how far is ship from the lighthouse. Means we have to find out the distance of this. How far is the ship from the lighthouse? Okay, this we have to find out. This BC's distance we have to find out. So we can denote it by X. So here what you have to write? Let AB represents the, let AB be the height of the lighthouse, which is equal to 90 meter. Okay. Now next what they have said, that where is the ship? Ship is at the C point. So C is the position of the ship. C is the position of the ship. Now next what they say. Now this AD here, this name you can give D. Okay, so AD is the horizontal line and AC is the line of vision. Okay. Now horizontal, and it makes an angle DAC, which is equal to 60 degree, and this angle AC CB is also 60 degree. Alternate angles. Okay. Alternate angles. Now see, now here this B angle is right angle. In right angle triangle, in right angle triangle ABC. Okay. So here what tan 60? Tan 60 is equal to what? Opposite AB upon BC. Okay. So AB is equal to 90 upon BC. And tan 60 is what? Tan 60 is equal to root 3. Okay. Now see. So this value we will write here. Root 3 is equal to 90 upon BC. So which is equal to what? Therefore, BC is equal to 90 upon root 3. See, when root 3 comes in the denominator, you have to rationalize the denominator. Okay, therefore, BC is equal to 90 into root 3 upon root 3 into root 3. So, which will be equal to 90 root 3 upon 3, which will be equal to 30. So, 30 root 3. So 30 root 3 is the distance of the from the ship is from the lighthouse. Distance from the ship to the lighthouse. Now root 3's value you can write. Root 3's value it is what? Root 3's value is now 30 into 1.73. So it will be equal to 51.9 meter. Okay, 51.9 meter. The ship is at a distance of 51.9 meter from the lighthouse. Okay, at last what you have to write? The distance of the ship from the lighthouse is 51.9 meter.